Okay, let's continue. We've heard in the past two excellent presentations, we have already seen the trend that processes are getting quite an issue in this new world. So it's very interesting to hear the perspective of the MEF, and I'm not saying the full word as I'm not supposed to, the MEF. I'm very happy that Bob came over from the US, having a strong European past.
Background, yeah.
So the floor is yours, Bob.
Thank you. So let's just start. I'm going to assume that some of you don't know all about the MEF, so similar to Steve and to Sandra, I'll talk a little bit about the MEF. Its official name now is MEF Forum. It began its life as the Metro Ethernet Forum. And let me get to, here we are, the legal name changed. So the MEF today has 220 members. You'll see that there is a predominance of service provider members, and that trend where the membership became dominated by, was taken over in a sense by service providers in more ways than one. Their influence is very strong within the MEF. Began about 5 years ago. It was essentially a vendor-driven organization to begin with listening to service providers. Today it is a service provider-driven organization telling vendors what to do. And you can see that the spread does show North America as being the source of most of the member companies. And you can see that EMEA is then the second strongest. And when I finish my presentation today, I would expect you all wanting to sign up. So that'll change the pie significantly. At least that's going to be one of my hidden objectives. So as we actually together, there were a number of people at the MEF that helped put together this presentation. Also Shahar, I'll introduce him very briefly, who was chairman of the Service Operations Committee, and we'll be talking quite a bit about the work of that committee as I progress. So the research that we've done basically tells me, and don't correct me if I'm wrong, that regulators in Europe are really focused on broadband services because of the relationship of incumbents and the strength of the incumbent position as compared to alternate providers. The MEF is not about residential broadband services. The MEF defines, let's call it business services, but also backhaul services, but also services that reach the cloud. But these are point-to-point private or virtual private services. And so they touch the business world. And in the business world, the problems that occur in broadband in the residential space just don't reproduce themselves. And so the general impression that I got in phoning around and trying to inform myself is that what we call carrier Ethernet, the MEF, and which maps on quite well to what the Economic Commission refers to as Ethernet leased line, is generally speaking less subject to debate and to issues in the European regulatory space. And I think as we go forward, this relative hands-off of regulation on the carrier Ethernet space will only progress. There will be less and less hands-on because of SDN and NFV and another concept that I'll be introducing to you. So the MEF began its life with a very simple problem. Ethernet dominated enterprise networking something like 90 to 95% of interfaces were Ethernet interfaces. It was discovered that Ethernet then suddenly had reach and speed that made it interesting, at least in the metro space. And so a few metro service providers and vendors got together and said, vendors sell Ethernet in the form of devices. We don't sell service providers don't sell devices, they sell services. So what would an Ethernet service actually look like? And being ambitious, the MEF decided that in defining what's now called carrier Ethernet services, they would go after real business. They would define a service based on Ethernet that would go straight up against leased line services, straight up against frame relay, straight up against AT&M to get market share for carrier Ethernet services. And that's been largely successful. You can see the bragging rights apparently work out to be an $80 billion plus global market for carrier Ethernet services. So it is a substantial market. And if you look on the right-hand side, next slide. If you look on the right-hand side here of this particular graph, you will see that carrier Ethernet services are projected to reach about $22.5 billion in 2020 in EMEA, as compared to, and you can see you can probably make out the other numbers if you have good eyesight. So I just want to make it clear at the beginning that everything that I will be saying will be with respect to what I call carrier Ethernet services, what the MEF calls rather carrier Ethernet services, that is commonly called, in the context that we're speaking here today, Ethernet leased line. Almost none of anything that I will be saying will have to do with broadband services and the regulation of broadband services in Europe. So, in answer to, in anticipation of a question, if Wilhelm were to ask me a similar question to earlier, Steve made the remark that SDN and NFV can't get the whole job done all on its own. The MEF has created a program called Unite. And the objective of Unite is to recognize that similarly the MEF cannot get the whole job done on its own. And so the MEF now has very close, not formal liaison type relationships with SDN and NFV, with ONF, just as a couple of examples, but also ITU and also IEEE, but working relationships where engineers, where standards people, where code writers sit down, where information model creators and designers sit down together and work for the common good, with a clear understanding of the areas of responsibility, the more specific areas of responsibility of each one of the organizations. And that leads me to say that the area of responsibility of the MEF has dramatically expanded, and a lot of what I'm going to be talking about today will be an attempt to explain what this expansion is, has dramatically expanded from the base mission of the MEF, which is to define carrier Ethernet services, of which there are retail services, EPL, EVPL, ELAN, and so on and so forth, and wholesale services, e-access and e-transit, all of which, by the way, are come under the MEF certification program. And on Monday, there will be an announcement for the certification of Carrier Ethernet 2.0, new e-access, augmented e-access services, and brand new e-transit services. So that's a big step for the MEF. Now, once we have services in place, the MEF really had to deal with a new problem, a new set of problems, service providers needing to scale. The manual configuration of services using the manuals of vendor A and then vendor B and then vendor C and then vendor D is not a way to scale, and it's very costly, of course. And so the notion of a common management for that allows the configuration of all devices through commonly defined and accepted APIs, again, specifically for carrier Ethernet services, was the first step into a lot of reflection and a lot of thought by the MEF that has now resulted in the concept of LSO, Lifecycle Service Orchestration, which is a much broader concept that began again with a notion of we need common management at the device level, now to a much broader notion of what management needs to be as going forward. A management that can embrace IP, a management that can embrace the communication between service providers that was discussed earlier today and that I'll be discussing quite a bit later on, that I think is absolutely critical to any reflection by regulators about carrier Ethernet. Just one final thing. I did mention earlier that in defining carrier Ethernet services, the MEF was going for market share very explicitly. Let's do a better frame relay by basing it in Ethernet, basically, was the war cry. Beyond that, sorry, let me just. My jet lag just set in, and whatever I was going to say escapes me. So let me just move on to the questions. Sorry, now I do remember. What I wanted to say is that the way that the MEF defines services technically clearly defines interfaces, clearly defines the responsibilities of buyers and the areas of responsibility from a technical point of view of the buyers and the sellers of carrier Ethernet services. So if we're talking about a wholesale access carrier Ethernet service, there is a UNI interface that's well defined. There is an ENNI interface where the the service provider and the so-called operator meet. But who is responsible for the filtering of layer 2 control protocol frames? Who is responsible for bandwidth profile? Who is responsible for setting MTU? All of this is defined in carrier Ethernet services and very clearly defined. I have a hunch that because of these very clear definitions, it wasn't nearly as necessary for regulators to get involved in carrier Ethernet services because the broad adoption by the industry in Europe, all over the world, of these carrier Ethernet services clearly defines interfaces and clearly defines responsibilities in the first place. They aren't discussed, it's done, and it's accepted by the industry. It seems to me that in the broadband space, there's much less clarity around interfaces and responsibilities, and this gives rise to the necessary regulation of the relationship between buyers and sellers through regulation, is the point I wanted to make. Okay. So, the questions, of which there are 5. And I'm sort of going to skip one. I think the OTT one is one that I don't... for point-to-point private services, OTT doesn't really come into play that much. So, question number one. Yes. Yep, I'm looking at the little one here in front of me. Yeah, okay. So maybe by now you're somewhat familiar with the questions, having seen them come up 2 or 3 times already. The simple answer to the first question, do SDN and NFV enable greater access? Now, clearly the vocabulary of this question is very broadband oriented, right? Because in the carrier Ethernet space, one doesn't really talk about that much about incumbents and alternate providers, and certainly not about Ethernet bitstream, and even less about VULA. So I'm going to have to transform this question into an answer that would be relevant to carrier Ethernet. And in order to do that, but you do see the answer is yes. In order to do that, I'm going to just back up and do something very simple, and I'll try to do it very, very quickly. As I was saying earlier, the MEF defines carrier Ethernet services. Here's a schematic of a very simple schematic of a wholesale, so any access service, right? So you have perhaps AT&T, Steve's company, that needs to reach a customer in Poland. And so AT&T will seek a partner service provider in Poland that will provide the access to the customer site, let's say in Warsaw. So this is where the EN and I has been the subject of an enormous amount of work. The definition of the EN and I interface by the MEF 26.1. It's about to become MEF 26.2. The UNI is where we have the customer site in Poland, in Warsaw. The UNI is defined in MEF 10.2, about to become MEF 10.3. These are very substantial specifications. They're generally divided into 2 big pieces: the definition of the interface and the definition of the connection between the interfaces. So the connection between the interfaces is where SLAs come into play, for example, because delay, as an example, is what happens between interfaces but not at an interface. But the filtering of some layer 2 control protocol frames so that the network behaves properly does happen at the UNI. So there are attributes that are related to the one and to the other, generally, is how this happens. The interesting thing here is that you just see boxes. And this is where the MEF, these are the tools that the MEF had to work with, so that you can see that there's a box in the customer site, there are a couple of boxes at the EN and I, and then there are probably a whole bunch of boxes in the middle that are not of concern to the MEF. So if we just go forward a little bit, and if you just look at the bottom of this slide for the moment, it's not dissimilar to the slide just before, but the boxes are gone. The boxes will not disappear. But in addition to devices, boxes, one may expect, if all goes well, and Steve does his job well, and Sandra does their jobs well, that boxes will be replaced by virtualized functions, so that firewalls that are appliances today can be essentially software implementations, and I'll talk a little bit about how that would look in a network and how that would be integrated into a service itself. So all of this is, so what these 2 slides are telling us here, you'll see that there's a blue side and a gray side. I'm slightly colorblind, and if it's not blue and gray, it's something else. But you can see that they're distinguished. So there's an operator A, an operator, excuse me, is 1 and 2. So now let's think a little bit about operator 1. So operator 1 is using SDN software at the control layer, northbound, southbound interfaces he has running. The operator may be implementing or offering some virtualized functions. And the same for operator 2. Now, we do have the Ian and I interface between the two if this were, as in the previous slide, an Ethernet access service, right? So now we have the problem. Okay, so we can think about operator 1 functioning pretty much independently and happy in his world. And the earlier presentations today showed us in much more detail what that looks like or will look like or will hopefully look like. And same for operator 2. Now, let's think in terms of MEF, and now we're thinking in terms of services. Now we need to create an end-to-end service, and we need to do it efficiently. And we need to do it not for these 2 providers, but for all providers. All providers that want to interconnect need to be able to interconnect their new NFV SDN stuff easily, but also their legacy stuff easily. And that is simply not available today. There are a couple of, I guess, private software companies that have management software that sort of kind of speaks to this, that, and the other device. But that's far from an industry-defined, accepted, common standard for managing devices. Now this is north-south, and now let's go up just a little bit. And you can see that there's an east-west connection between the two up at the top. This top, do I have a thing here? Let's see if it works. Here, this one here. So what the MEF is the grand new project of the MEF is to take a step up from services. And now let's think just a little bit. Do we just want to run the services? That's to say, figure out how to configure devices so that the service will be running end to end? Or do we want to come at this in a more in a more holistic way? Don't we want to ask ourselves the question, well, now, wait a minute. To get that service in the first place, it's going to have to be ordered. In order to place an order, you have to be able to look at some kind of a catalog. What if there's no standard for catalogs? And what if there's no standard way of ordering a service? Again, a carrier, for the moment, a carrier Ethernet service. Then the usefulness of having a common, at the configuration level, a common standardized way of achieving this will not help service providers all that much, because they will still have to overcome the hurdle of trying to figure out what services are actually offered by their partner service providers in detail. And if each service provider describes this differently, we won't have a complete solution. So what we have to start looking at, thinks and says the MEF, is the complete life cycle of a service. And that starts with a catalog. Then we have to think about ordering. We have to think about billing. We have to think about performance reporting. We have to think about configuration. We have to think about maintenance. We have to think about all of these different things. So Shahar, who is co-chair of the MEF Services Operations Committee, a newly formed committee, has charted out a work program, I guess we can call it, to build a framework for this. And so quite naturally, it's called Service Life Cycle Orchestration, which is the term orchestration is just a grander notion of management, what we would normally call management. Now, service lifecycle orchestration is slow, and so that's not acceptable from a marketing point of view, And so indeed it's called LSO, Lifecycle Service Orchestration. That's the objective. Now, the MEF is fully aware, and many MEF members participate very heavily in SDN and in ONF, just as an example. And so LSO must, from the start, be thought through to have capabilities that allow service providers, not only in their own silos, but between silos, to manage virtualized functions, and to do so harnessing the strength and power that SDN software-defined networking provides. And so you can see that with this strong focus on services, you can now see how, from the MEF services point of view, NFV and SDN fall into place, but they fall into the place under the umbrella of this new concept, LSO, Service Lifecycle Orchestration. But Service Lifecycle Orchestration is nothing without the MEF services getting the work done at the let's call it the infrastructure layer. So LSO isn't this thing that's just floating floating around. It is very much grounded in MEF-defined carrier Ethernet services, because the MEF is solidly convinced that the definition of carrier Ethernet services has been an enormous help for the development of carrier Ethernet services. And because the MEF thinks that there is not an equivalent in the IP space, a new set of work has been proposed within the MEF to start the development of the definition of IP services, somewhat along the lines, somewhat using the basic framework that the MEF uses for the definition of Ethernet services. So you can see that the MEF, in adding this new layer called LSO, at the same time, it is addressing a broader space of services. And this broader space of this broadening of the space of services begins with IP. LSO is new. Work on IP services is new. There is another very interesting proposal that will be presented to, it has been presented publicly within the MEF, and it will be presented to the board, and I would expect next week it will be accepted. And this has been nicknamed OpenCE. OpenCE is trying to define carrier Ethernet services. I can't see. 2 minutes. Okay. Trying to define carrier Ethernet services for the purposes of using, NFV capabilities. So let me get to. So what the MEF says in question number 1 is very simply, yes, alternate SDN and NFV do provide alternate network operators more control over incumbent networks, but then the MEF considers that it needs to do the work that I've just described under LSO in order to achieve that really and fully. So, will SDN and NFV also be standardized in a way which will make such forms of network access possible? The thinking here is that open interfaces need to be developed. APIs need to be developed in order for these new forms of networking to provide multi-operator management and orchestration. And so that's what you see illustrated here. As for vendors, let me just go forward here very quickly. Here's a slide where the MEF speculates a little bit on how does NFV affect the definition of services itself. And what you can see is that an EVC, which represents the connection of an Ethernet service, could be affected in many different ways by the introduction of virtualized functions. The virtualized functions could be sourced at provider edge equipment and therefore be largely controlled by the service provider itself. They could be sourced in a data center with different ownership. They could be sourced within the cloud as a cloud service is generally available to everybody. And so if the data center belongs to I guess what this is suggesting is that service providers can take on board new NFV functions in very different ways that have fundamentally different market mechanisms going to work. And the creation of cloud-based NFV functions that could be purchased directly by the end user or could be used by or sold through the service provider to the end user creates a model where if the integration of such functions become part of the service itself, it seems to me that for regulators this would create an absolute nightmare of difficulties in trying to distinguish the different responsibilities of the different actors that are responsible for the creation and the delivery of the service in the first place. So the challenge, I think, is something, however, that regulators do not have to worry that much about, because we will see the marketplace figuring out whether NFV services, when they do come to market, really will be sourced more by within service providers and offered by service providers right on the network through data centers, or indeed by third-party cloud-based third-party cloud-based providers. Maybe I'll just end with this particular depiction. LSO is a grand concept, and so this particular slide indicates that it is concerned with the relationship at the application level between a buyer and a seller service provider. This is again essentially for carrier Ethernet services, and it's given musical names. That's called Sonata. There is another east-west interface called Interlude, and then you can see a number of north-south interfaces. There was mention earlier about ONF Plugfest and so on. There has been an initial MEF hackathon which included about 40 participants developing API code for the Presto, the North-South, and the Adagio interfaces, but heavily influenced by the work of NFV and very heavily influenced also by the work of SDN. This is just an illustration of the kind of thing where when the MEF thinks about the network interface device, a NID, this is just an illustration of the integration of NFV functions inside of a NID, and how one has to think about embedded capabilities, about virtualized network functions, and then about value add virtualized functions. And you can see that this can very quickly become very complex. from a regulatory point of view, the boundaries become very unclear. It doesn't seem clear at all whether regulation is needed in the value add space, in the virtualized function space, or indeed in the embedded, the initial physical, essentially physical layer. I'm sorry, and that was here. So you can see that the complexity by introducing NFV into what otherwise would be a simple user network interface is enormously expanded with the introduction of NFV functions. And that answers the value chain question also. So the other regulatory implications of SDN and NFV would be summed up, I believe, by the MEF by pointing the regulators to the work of the Services Operations Committee. Again, thanks for the presence of Shahar, because the MEF believes very strongly that without creating a common language for service providers as they buy and as they sell carrier Ethernet, and indeed going forward IP services, that without creating that common language and getting industry standards aligned for that to occur, the existing, let's call it proprietary boundaries, will still dominate. Once we have LSO, boundaries will fall because the communication between buyer and seller will be open, and if it's done properly, will allow all service providers to receive transparent and equal treatment. And I've probably gone over time, and I'm very sorry.
Bob, thanks very much. Are there immediate questions to the presentation? Since we are over time, there's no one asking to speak.
Okay,
Then
thank you.
Thanks very much. But in fact, you really pinpoint the matter with the different agents that may be subject to regulation due to bottlenecks. So we do have challenges here. We now have a switch of speakers. We've now heard 3 speakers from the standardization organizations. We're now moving to the operators, and I'm introducing Emmanuel Tricaud to you, who is Director Regulatory Affairs of Colt Technology. So we are very... I'm a bit relieved because there's one economist speaking here. So I'm looking forward to your perspective on the topic.
Some difficulties, actually. Good morning. So, well, I guess all of you have heard of Colt. You might not know in detail who we are. We are a fixed business telco, an infrastructure player. We think that we're relevant where we have our infrastructure. We mean by infrastructure where we can activate passive infrastructure, either our own or fiber that we rent. Our network is mostly based in Europe. We are in 28 countries, but 18 of them with not only with points of presence, but with metropolitan fiber networks. Most of them in Europe, and also a bit in Asia, in Tokyo, Seoul, Hong Kong, Singapore, and with points of presence in the United States and Australia. well, our relevance is on net, but the RFPs of our customers do not stop where our fiber stops. This is why we need off-net. However, we never answer an RFP if I would say the off-net component is too big. It would not be our sweet spot. It would not be relevant for anybody. If we take Q1, question 1 from berec about SDN and NFV, we say that, of course, more control over third-party networks through SDN and NFV is possible and welcome, but in no way it is a substitute to access to passive infrastructure. So I would say VULA is not a panacea. On the second aspect of Q1, which is, will SDN and NFV be standardized in a way which allows such form of network access to be possible based on SDN and NFV with multi-tenant support? What we can say is that we have more than, I would say, 500 ENNIs that are live. So we buy and sell to that many operators. However, we cannot afford to make the investment to automate with all of them, clearly. Of course, we face different interfaces. Let's take an analogy. Let's take the analogy of what has been done in half European countries for number portability, exchange requests for number portability. This has been done in Switzerland, this has been done in the Netherlands, in Belgium, in France, in Spain, in Portugal, although not in, I would say, the UK or Germany or Italy. And this is the creation of a standard hub between operators that allows the exchanges to be done through this hub. The fact that they are done through a single hub makes it possible to screen the request and to check that it is conformant to a given API specification or to a given object behavior behind the API. And typically, this reduces the cost of developing proprietary bilateral exchanges, which is n times n minus 1 divided by 2, into the cost is only n, and even for a single player, it's only 1. So it's clearly something that is a way to organize exchanges, which more or less forces convergence. On question 1b, will SDN and NFV also be standardized in a way which allows such a form of network access to be possible? If you see our architecture, something that is you are very familiar with this layer structure, we can see on top that the user of our northbound APIs can be either direct customers, or it can be, I would say, the customer themselves build a portal for the services they provide within their organization, or it's other operators that are using our APIs. This is why there is a variety of uses of these northbound APIs. When we discuss SDN today, we face very different reasons to be excited about it from different customers. you know, whether they are big financial information providers or big banks or operators. The reasons to find an interest into what SDN brings can be very different, and they will integrate it into something different. Of course, on the southbound side, we have to manage the different classes of equipment that we have, whether for modular Ethernet access, IP service at the edge, or you know, the optical network at the core, or all the third-party network infrastructure that we are using. So, question 1C, will SDN and NFV also be offered by vendors and open source? I would say, of course, I would say this is absolutely necessary, but it should not start with, you know, future standardization. It starts with what we have today. We didn't wait for having standard interfaces from device providers in order to move into SDN. What we have done is that we have successfully deployed, thanks to you know, carrier-grade Ethernet, a management platform that manages 3 different vendors. So Accidion, Sienna, and Alcatel, now Nokia. And they are managed by the same platform. And this is what makes it possible for us to offer, I would say, the SDN service, which I will describe. So, okay, SDN is now a reality in Colt, a commercial service. It has been like that for you know, a couple of months now. And the first service we have rolled out is called DCNet on demand. DCNet for data center network, of course. So it's a data center to data center service. So what does what are the SDN functions that are concerned? Well, it's first about reserving and releasing ports, creating connections between these ports, and modifying the bandwidth between of these connections. And typically, the data center can be in the same city or in different cities on our network. The granularity that we have defined is typically that ports have four levels of bandwidth: 100 meg, 400, 1 gig, 4 gig, and 10 gig. For the ports, there is a minimum contract term of 3 months, and for creation of the port, we charge something. The connections, of course, there is a one-off charge for the creation of the connection, a recurring charge based on the bandwidth, and it can be flexed. It's not like, I would say, a phone call, something that is measured and billed in seconds, but the units is the hour. And there is no minimum contract term. You can, order some bandwidth for 1 hour within a connection that is live. Now pricing. This is interesting. Typically, as I was telling Cara during the break, we have done a lot of network costing modeling for either cost accounting reasons or for regulatory debates, and this was all about the cost of the network, on which you could placate a standard known fixed demand function. Here, it's a variant of a static demand model that we know, but we don't know at all what the customers want to do with this flexibility, and we don't know what is important for them, we don't know the value to them of this flexibility. So in order to begin, we have decided that the flexible variant of the service, DCNet on demand, will be 20% more expensive if the customer did not make any use of the flexibility than the standard variant. So if you order a 10 gig for 3 months or for 1 year, let's say, it will cost you 20% more if you don't change it than if you had ordered a fixed service. And we shall see. We shall see whether customers are using, I would say, go down to 100 meg for 90% of the time and go to 10 gig only for 10%, and whether they will consume more, whether they will consume less, will adjust. But we don't know. Trial and error. So we have a proof of concept that is going on with another operator in the room. And as you see, it's about carrier Ethernet services, and we work at both sides. They OSS BSS using our API and our service abstraction layer, targeting their own service abstraction layer API. We hope that this will materialize into a live service in the coming months. Regarding NFVs, well, here I am beyond live services. It's just, I would say, the result of our internal sessions about gathering possible ideas. So here are the kind of services we imagine as possible virtual network functions. We see that more at the IP level. So for us, more or less, it might not be the case 2 years from now, but today we see more SDN be relevant at the Ethernet layer and NFVs at the IP layer. So what will be the impact on the value chain? As I mentioned it, I would say this initial flexibility premium of 20% was just to get the ball rolling, and we have to discover what customers will do with the product. What will be the appetite for it? How this will change their consumption, and this, I would say, will be a challenge for regulators. Regulators are not used to regulate unknown, unstable, unpredictable demand, so I don't think that any modeling can substitute for live experience as the market will develop it. Now, if we look at OTTs, OTTs have a network, more and more of a network. They have, of course, a data center network. They are trying to build points of presence closer and closer to the access providers. So I would say it's likely that the usage of the OTT services will require customers to ask for some specificity. Typically, I would say regulations about data location and make things different in this domain, but there will be also consideration about resilience, where do you put, where do you replicate data, and so on. So I expect the dialogue between end customers, access providers, and OTTs to develop, and this will, I would say, SDN and NFVs will push the, I would say, the OTTs into being more transparent in terms of what they offer. Where are we now? I would say we are at the initial commercial offerings at a small scale, on net, at a retail level or at a wholesale level, because for us we offer more or less the same products to end users, to big corporations, as we do to operators. We would like very much to be able to buy similar services from other operators, and we approach all our major, I would say, supplier customers in the operator domain with such requests. We have a couple of proofs of concepts going on. We are eager to get more of this running. When will this turn into interoperation commercial offerings, apart from our own offerings? Well, this year, next year, that's what we hope.
Thanks, Emmanuel. So, are there questions to this presentation?
A short technical question. You have mentioned that it's possible to set up for the customer Ethernet connections between pre-reserved ports, and that he can modify the bandwidth, for example, which is used for 1 hour. Yeah. What is the limit to reduce this? Maybe also to half an hour, 10 minutes, or then it would really be rather similar to a phone call where you actually have no connection, but the customer needs to have pre-reserved port, and then he can actually just use the service if he would like to transfer or exchange data with other customers, and then it would actually not use it. He would decline the configured bandwidth to 0, and then if he would like to, let's say, call another business customer, then he can configure a bandwidth, let's say, from 1 gig, and for 10 minutes, and after 10 minutes they have exchanged with the guaranteed bandwidth and very good quality of service, the data, and then there's no further demand for, let's say, some hours, and then he can exchange data with another business customer. Of course, it would make the problems you have mentioned in your presentation even worse. It's not much more too difficult to predict, which would means this for the service provider in reference what bandwidth has to be preserved for the services.
Yeah, you know, as you mentioned it, there are two sides in your questions. What is technically possible and what is the business implication of it? What is technically possible? Well, I would say this lies in the OSS. The performance of the OSS, which is a big database somewhere in the cloud, which, you know, handles in a real time the configuration of the network. And we push it to its limits. We have known some, breakdowns of the OSS platform that have, infuriated our customers in the last months, and rightly so. I would say the level of reliability of the OSS platforms is typically what will drive this frontier. Now you have the business proposition, and I would say, since we don't know, we will listen to what our customers are requesting. And I would say it's by exchanging with them, by showing them what we can do. They will come up with further requests. Maybe it will go in the direction that you are aiming at. Maybe not. Let's see.
Any other question? That's not the case. Emmanuel, thanks very much. Let me now introduce Markus Henrich to you, who is head of telecommunications at QSC. I think his career is an example of that change is possible. He has a degree in business psychology and now has been responsible for network dimensioning, etc. at QSC. So we are interested to hear the perspective of another network operator to see how you are dealing with SDN. Thank you.
Thanks, Cara. So looking at the schedule, it's just me and my presentation between all of you and the lunch break. So I'm trying to get you through this as quick as possible, promise. Okay, my presentation mainly is about a potential use case of what SDN could do in next generation access, how network topology could change, and how the efficiency of networks could be enhanced by using SDN in access and aggregation networks. But first of all, let me give you a short introduction what QSC is about, because I'm afraid that only very few people in this room might know QSC as an operator. For those who come from Germany, there's another company called QVC, which is a teleshopping company, but I'm not here to sell you any jewelries or things like this. QSC has a strong background in being a pure telecommunication operator in Germany. We are doing telecommunication for more than 15 years right now. But over the last 5 years, we are more and more moving on to be the digitizer for the German SME sector. We are focused on business customers, and we don't serve them only with pure telecommunication services, but more and more with IT services, with the whole value chain, what a German SME customer needs and wants to have. So we are dealing with software-defined networking in our data centers for years now, and we are on the move to bring software-defined networking even to our transport network. And we are looking to enhancing this situation. We have our own data centers, like here, and just give some rough figures about QSC. We are, in comparison to the big operators in the German market, really a small company with 500 million of revenue and 1,600 employees right now. Not the biggest ones, but we are focused, as I said, on business customers mainly. To come to the effective topic of the presentation, the next generation access situation. In Germany, if you look at the specific market of Germany, it's a market of reselling lines. If you look at the overall figures, Deutsche Telekom is the incumbent in the German market. I think 2 of the guys are in this room. Deutsche Telekom, from an infrastructure perspective, has more than 40% market share from a customer perspective, but they also use their network to serve others with network services. The number 2 in the German market is the company 1&1, United Internet, and the funny thing and the very special thing about this is United Internet doesn't own any own infrastructure. They are doing all their network services on the base of network of others, and the German market overall is a market that is used to selling and buying services from others, because there are no 2 or 3 big countrywide operators which can compete on a fair level, but there are this one big operator and another successors and a lot of other smaller companies who try to get their market share, but none of them can effectively and efficiently build up a nationwide network to have a real competition in the market. So competition is mainly driven regionally. There are strong operators in a specific region, like Net Cologne, which is only serving the countryside of Cologne, or Mnet in the Munich area. But on a countrywide base, there are only 4 companies offering services countrywide. But as we've seen from the sketch before, one is very big and all the others are quite small. So to be nationwide, to have a coverage which you can really sell on a nationwide base to your customers, you are always relying on the network of others to extend your footprint. We ourselves, we have a footprint of 85% of the households in Germany because we are mainly focused on business customers. And we only erect our network in the cities where business customers are located. But you also have SMEs, you have small home offices you have to connect. So we rely on network access of third parties. And this is what I'm talking about today. As of today, the majority of the network, the access products you buy from other networks are based on L2TP, PPP and L2TP connections, so to say a layer 2 overlay over layer 3 networks, which is technically set up like this. You have the access network from yourself on the right side here. You have your access layer, you have your distribution layer, your aggregation layer, and your network-to-network interconnects, and you have the network of the others to serve you with access mainly. But as of today, all those networks are isolated and have near to no knowledge from each other from a control plane perspective. So when a user tries to dial up over the network of, for example, Deutsche Telekom, he will enter at the DSLAM area or multi-service access node when you're talking about fiber nodes. But the DSLAM area or the distribution network has no knowledge about the customer-specific preferences. You don't have the idea, the intelligence of what service the customer should have at the access layer. So from this perspective, you forward all this traffic as transparent as possible to a service aggregation layer where you can set up the effective service that the customer should need. So the DSLAM and the label edge router, the distribution layer, do not know if customer A is an on-net customer from Deutsche Telekom or if it's a wholesale customer of somebody else, what service should be terminated effectively. So you have a lot of traffic running from the access over the distribution up to the aggregation layer. We are then an intelligent device like a BNG, a broadband network gateway, will do the decision what this service should be about. Normally, the BNG then, in a wholesale scenario, will set up an L2TP tunnel running over the IP core network, transporting the packets to the BNG of the other operator, like this. And because the networks are not connected on a control plane layer and have near to no knowledge about each other, the traffic is transported over the IP core, which in some parts can be the same than the distribution layer. Need to send to another network and transport it in this other network and go back to another BNG, which then is owned by the effective operator. And there the decision can be taken, what IP should be terminated, is this an internet or an VPN service, what QoS profile should be there. So in this sketch you can see that traffic is running over different topology layers, over a lot of connections, a lot of active devices to be transported between two customers. This is, from an overall perspective, not very efficient. You have the same kind of devices, you have the same intelligence in both networks. A BNG is there on both sides, but because those network devices are not connected, you pass unnecessarily number of devices, you have a lot of capacity installed where the traffic is going through, you have a lot of redundancy in place, which you don't need if you would know about the effective path for the user. So, and this is the layer 3, the existing L2TP setup, which is in place. For IP, it's already set up, it's pretty easy, but we are moving towards layer 2 bitstream. There are a lot of movements in the German market, partly from the regulation. VDSL vectoring is deployed, and you are no longer allowed to deploy your own network in some special areas, and it's not very efficient from a commercial perspective. So the movement towards next generation access being based on layer 2 bitstream are on. So as we've seen here, we are moving from layer 3 bitstream towards layer 2 bitstream products. But in layer 2 bitstream, there are not the mechanisms we might have in layer 3. The intelligence of the IP routing, of multiple exit discriminator, BGP parameters. So going to layer 2 bitstream might be more challenging because of the Ethernet protocol in first place. But on the other hand, due to the regulatory situation, when you buy a layer 2 bitstream in Germany, this should be handed over as close to the customer as possible. So while layer 3 bitstream was more or less a centralized handover with an NNI, where you could aggregate all the traffic, the layer 2 should be handed over as close to the customer as possible. So taken from the example of the network of Deutsche Telekom, they are planning to build up a countrywide network for layer 2 bitstream distribution, and they are planning to bring the intelligence and the network intelligence, which was previously on the BNG, some centralized, close to the customer. So while we are today talking about software-defined networking, where more or less the control plane and the network intelligence should move to a centralized cloud infrastructure to new modern situations, I see one network going the way to not bring the intelligence to a cloud orchestrator, but to physical devices, which now are no longer centralized, but get closer and closer to the customer. The network topology of Deutsche Telekom, just as one example, is planning to bring the BNG closer to the customer. This is okay because you don't have to bring the traffic all over the network towards the centralized BNG and intelligence platform, but you put quite intelligent and quite expensive boxes closer to the customer, bringing to the countryside, which from my perspective is not very efficient. Now these BNGs, which are deployed there, are do nothing else than to make an Ethernet switch decision, because we are talking about a layer 2 bitstream product. So the traffic from the DSLAM is brought to a very intelligent BNG platform, which does nothing else than decide where to switch a packet, because it should be forwarded to another provider's network. So from this BNG, you have a local connection, which is not very intelligent, which is not linked to the effective service creation point, and you transport them from, in this situation, 900 local handovers to your centralized network platform. And once again, you have the same functionality, the BNG, at 2 points in 2 networks, while effectively one customer server should be created. So now, again, from a BNG over distribution network to another BNG, just to find out what the effective server should be about. And this is not only for the network of Deutsche Telekom in this case, but also for our own network, where we are not only purchasing wholesale services, but we are also offering wholesale services, and we are purchasing the same service from all the local carriers and all the networks which might come up. So the bottom line is, in both layer 2 and layer 3 options, there are 2 separate networks, which from today's perspective have near to none knowledge from each other. So you have 2 service creation points, you have 2 authentication mechanisms which are not linked to each other, you have 2 networks which pass the traffic and which need to have capacity for this. In layer 2 scenario, additionally, you have those infrastructures very close to the customer, which from a cost perspective might not be suitable, I guess, while even the label edge router could, with a centralized control plane, do the same job, but by the way. So what if both networks would use one and the same control plane, which is then centralized by SDN and NFV functionality? So combining 2 networks to one logical network, or giving some kind of network steering and network control to somebody else, might sound weird in the first moment, but effectively, as of today, we are doing things like this for a long time. So if we're talking about L2TP and layer 3 forwarding, there are options in the BGP protocol which give you network control over the forwarding path and other providers' networks. So if we are exchanging IP traffic with other networks, we can steer them by multiple exit discriminator, by RS path prepend, by communities to make a decision where the traffic should be handed over. Or think about mobile networks where the MNOs and the MVNOs talk to each other over a standardized camel interconnect, where the MVNO can have call control over the physical network of the MNOs. So from a single network protocols perspective, we are doing things like this to give somebody else a control over the network flow. The traffic flow in the network in general is already there, but it's not on a global base and it's not protocol independent. If I think about the approach of having layer 2 and layer 3, I think for a long time we will have layer 2 and layer 3 bitstream in parallel. So I need to have both infrastructures, and it would be of advance if I could use it as effective as possible. So the overall idea could be in an access and distribution network to have both networks in parallel, but to share a combined SDN orchestrator where information on an API could be exchanged, to give both networks the information what the service should be. For example, I could use a direct Ethernet connection from the DSLAM over the distribution layer to the BNG, orchestrated and configured from this centralized platform, going the local or the central interconnect, and I don't need to go through a BNG in the access provider's network. He don't need to know what the service should be. I just give him the information. I don't need to pass a BNG twice. On the other situation, if I already know what the IP service, it's a simple IP service I want to set up, what this will be about, and I pass the BNG of the access network provider anyway, then I don't need to pass the BNG of my own network for a second time. Talking about different protocols, I'm already purchasing layer 3 VPN services from other networks. I'm purchasing layer 2 VPN services from other networks. But this is all a static product I order, and it's pre-provisioned, manually provisioned by the network operators. For example, all these products I'm showing here are already there, but on a manual order base. So I already trust other network providers to do an IP service for me, to use their BNG to set up an IP address, IP VPN, virtual routing and forwarding, and have a predefined NNI. So why should I not automatically exchange those information and use their BNG as I do it today, but on a dynamic base? The big advantage about this would be it's cheaper, it's more efficient, it's easier to set up, and for both networks, the traffic flow would be enhanced. Because I, in both networks, know what is the source, what is the destination, what service should be created. Is it a layer 2 or a layer 3 service? Where do the packets need to go? I could use more redundancy, less interconnects, and from an overall perspective, really high level, this would be a big advantage to the cost of production, to the speed of production, to the flexibility in both networks. And as we are seeing the situation of having wholesale products buying and selling for the next 10, 20, 30 years, I guess, this should be a big advantage and a big enhancement. Okay, there the traffic is flowing more enhanced now. So in an ideal world, everything should be done by one centralized orchestrator. From my personal opinion, every network will be steered by its own orchestrator to take into consideration what physical network elements are there, but we should define some centralized API between the different orchestrators to give both networks the same state of information, be this the user information, the forwarding information, the switching information. If we share this on a per user base, then both networks could be enhanced from a traffic flow perspective. And the big question, what has all this to do with regulation? Because this is the major topic for today, with the regulatory implications. I think that the biggest benefits out of such an approach would be with the biggest networks. The bigger the network, the bigger the saving. So the big ones will benefit most from this, and this is mainly, coming back to the German special situation, the incumbent, which is under regulation. So using such an approach would be a big benefit from a price perspective, not only for the operators, but also for all the operators purchasing wholesale services from the incumbents. And if the price perspective could be enhanced, I'm personally thinking that also the regulation should take this into consideration, take this into account, and push that software-defined networking approaches should be in place as soon as possible, as quick as possible. We should work commonly on such an approach. 2 or 3 years ago, we had a voluntary working group called the NGA Forum, the Next Generation Access Forum, which was moderated by the Bundesnetzagentur, but not regulated directly. This was a working group where all the operators voluntarily worked on an approach how an interconnect could be about. And I would ask you, and I would like to see that something similar could also happen to software-defined networking, that under moderation of the regulator, all the operators should talk about an interconnect, talk about how we can commonly get those enhancements, how we could get this in place, and most of it speed things up. Thank you.
Markus, thanks for this burden.
You're welcome.
Kindly try to understand what's going on here. So I still have to learn a bit before the regulator can become a moderator here, I guess. Are there questions?
You said we several times. Sorry, thank you. You said we several times. Well, at the end you mentioned NGA. I agree this work needs to be done. It's very similar to the kind of work that I was talking about in the carrier Ethernet space.
Yeah.
Very, very similar. I think it's an easier problem to solve in the carrier Ethernet space because the service definitions are in place, the organizations are in place, the MEF is working with ONF, with SDN, for example. It would be interesting to speculate whether this could not provide some basis to populate the we that you were referring to?
Definitely. I think there are different approaches, different standards right now in place. But I don't see that one centralized API between two networks offering a variety of services, not only carrier Ethernet, but also IP services, L2TP-based services. There's a big variety of things which could be exchanged between two networks as of today. So from my current perspective, Metro Ethernet is one approach, but it does not yet cover all the demands you have. So a global approach, a combination, or a common agreement on a combination of standards and interconnects, I think this should be enhanced. And we should discuss this as soon as possible to bring also the standardization in the right direction.
I'd just point you in the direction of the UK NICC standards active line access stuff, which does pretty much exactly what you've just talked about. Looks a lot like one of Bob's E-line services as well. Obviously,
right.
From an NFV perspective, that's got a defined lead-to-cache interface using XML, but if you modify that approach, you get a layer 2 bitstream service that's end-to-end with a whole set of service wrapped around it. So that actually got contributed back into the broadband forum and it's very well specified. So I'm not saying it's the answer, but I would certainly point you to look at it because I think it probably does quite a lot of what you want.
But one major point about my presentation, I think it's not mainly about the technical standardization or the forums which are in place. I think the work has already been done. But what I doubt is the implementation. So this is the main thing about the regulatory perspective of this speech. So the technology is already there, but we need to adopt them, and we need to bring the operators in the situation, in the motivation to adopt to this. Okay.
Hello. Perhaps you say your affiliation, Chris, also?
Mm-hmm. Mm-hmm.
So Sven Heitzler from Deutsche Telekom. So just to mention, please do consider this on a European scale, not only on a national one. So
sure.
And please be assured we are aiming to implement those all for our entire footprint of 13 NatCos, and so this may take a little bit of time. And so as you said, it's of course we would see it rather in place earlier than later, but.
I'm pretty sure you're working on it, and I never doubt that you are working on it on a Deutsche Telekom perspective. But let's commonly discuss what an approach could be, because your network topology must somehow pay into or take into account what the API might be, what the demands might be. So talk to your customers. Any other questions?
Okay, now it's getting interesting here. I hope we'll deepen this discussion later on in the panel discussion. Markus, many thanks for your presentation. I think it was very interesting to have these business operator perspectives from both of you, and I hope it will fuel the discussion later today. We are now in the comfortable position to enter the lunch break 5 minutes early. So I'm just wondering whether we shouldn't, because we've foreseen, let me check. Sollen wir nicht sagen, in einer Stunde das reicht? I'm just wondering whether it could be now of our interest to reconvene 15 minutes earlier than what was foreseen. I think an hour is enough for networking, and then that would allow people to get home earlier. So I would propose we reconvene here at 1:30 in 1 hour and 5 minutes. That would also, in case the discussion heats up a bit, which I would appreciate in the afternoon, then we also have a little more time for the panel discussion. So let's get back here at 1:30. Savas, is there anything else I should be saying about lunch? Is it outside the room?
Yes.
Okay, so no place to find. So we just walk out of the room. Thank you.